Imagine a fighter jet that isn't just a single aircraft, but a whole system, a digital ecosystem of manned and unmanned assets, all networked together in real time, guided by artificial intelligence, and capable of dominating the skies well into the second half of the 21st century. That's not science fiction. That's the Future Combat Air System, FCAS. Developed jointly by France, Germany, and Spain, FCAS is the most ambitious European military aviation project since the Eurofighter Typhoon. But unlike past generations of fighter jets, FCAS is not just a jet. It's a network-centric combat system built around a sixth-generation fighter aircraft, swarms of drones called remote carriers, advanced stealth, cyber warfare capabilities, next-gen sensors, and above all, data superiority. At the heart of FCAS is the next-generation fighter, or NGF, a sleek, supersonic, highly maneuverable aircraft designed for deep strike, air superiority, and electronic warfare. This jet will be optionally manned, feature extreme low observability thanks to its advanced stealth shaping and coatings, and carry weapons internally to reduce radar signature. But what makes NGF truly unique isn't just its shape or speed, it's its brain. FCAS is built from the ground up to operate in what's called a combat cloud. This isn't just a fancy term for digital networking, it's a complete paradigm shift. The FCAS Combat Cloud will allow real-time communication and data sharing between the NGF, drones, satellites, naval units, ground stations, and even legacy aircraft. This interconnected web of assets will enable commanders to see the entire battlefield like never before, instantaneously, dynamically, and with unmatched clarity. One of the most revolutionary aspects of FCAS is the inclusion of remote carriers. These are drone-like unmanned aircraft that can act as force multipliers. Some will be small and disposable, used to saturate enemy defenses or jam radars. Others will be larger, more capable, able to carry missiles, gather intelligence, or serve as decoys. These remote carriers will fly in coordination with the NGF, providing protection, extending sensor range, and even engaging targets independently. Think of them as loyal wingmen, but smarter, faster, and more versatile. FCAS will also rely heavily on artificial intelligence, both in the NGF and throughout the combat cloud. AI will assist pilots with threat identification, mission planning, sensor fusion, and real-time decision-making. In many ways, the human pilot will become more of a mission commander than just a flyer. The AI will do the heavy lifting, analyzing data, recommending actions, and even autonomously controlling remote carriers. This AI-human teaming is critical for survivability in tomorrow's highly contested airspace. In terms of stealth, FCAS is pushing the envelope. The NGF is designed with blended wing body shaping, canted vertical stabilizers, and internal weapons bays, all optimized to reduce radar cross-section. But stealth goes beyond shape. FCAS is incorporating radar-absorbing materials, electronic warfare systems that can spoof enemy sensors, and even infrared suppression to reduce heat signature. This multispectral stealth means FCAS will be hard to detect across radar, infrared, and even acoustic domains. The cockpit of the NGF will be like something out of a sci-fi movie. Gone are the traditional buttons and dials. Instead, pilots will interact with the aircraft via augmented reality helmets, voice commands, and touch-sensitive smart surfaces. Sensor fusion will present only the most critical information, filtered and prioritized by AI. It's about decluttering the pilot's mental load and giving them more cognitive bandwidth to focus on mission objectives. Weapons-wise, FCAS won't just carry the usual mix of air-to-air and air-to-ground munitions. It will likely deploy next-gen hypersonic missiles, directed energy weapons like lasers or microwaves, and cyber payloads that can hack enemy systems mid-flight. The NGF and its remote carriers will be able to strike targets from long distances without even being seen, let alone fired upon. Another huge strength of FCAS is its scalability and interoperability. The combat cloud concept means that FCAS can integrate not just with new European systems, but also with existing platforms like the Rafale, Eurofighter, and even American assets like the F-35 or NATO AWACS. This ensures that FCAS isn't locked into a silo, but becomes a central node in Allied air dominance. But with such grand ambition comes complexity and cost. FCAS is projected to cost tens of billions of euros over its development and life cycle. The development is being led by Dassault Aviation, Airbus, and Indra, with each country contributing specific expertise. France leads the overall program and the NGF design, Germany leads the remote carrier development, Spain focuses on sensor systems and electronics. Coordination between these nations, while beneficial in terms of funding and political unity, also introduces challenges in aligning defense priorities and industrial interests. Critics point out the potential for delays, cost overruns, and bureaucratic bottlenecks. The program has already experienced hiccups, particularly over intellectual property rights and division of labor. However, supporters argue that these are expected hurdles in such a transformative and multinational effort. After all, Europe has to invest in its own defense capabilities, especially as the geopolitical landscape shifts and reliance on the US becomes less certain. FCAS is also a response to rival programs. The US is developing the NGAD, Next Generation Air Dominance, system. China is rumored to be working on its own 6th-gen stealth fighter. Russia, too, has the Su-57 and potentially a follow-on design in the works. If Europe wants to maintain air superiority, it needs something on the cutting edge, and FCAS is that answer. The timeline is ambitious. The demonstrator for the NGF is expected to fly by the late 2020s, with full operational capability slated for the 2040s. That may seem far off, but developing something as complex as FCAS takes decades. The technology has to be future-proof, modular, and adaptable to threats that don't even exist yet. That's why FCAS is being built with an open architecture. New sensors, AI tools, weapons, and even drone types can be plugged into the system over time. It's also worth noting the industrial and strategic impact. FCAS isn't just about building a fighter, it's about maintaining and advancing Europe's aerospace sector. Thousands of jobs, dozens of companies, and entire ecosystems of innovation are tied to this program. FCAS ensures that Europe retains sovereign control over its high-end defense technology, without needing to buy from the US or other foreign suppliers. So, what will FCAS mean on the battlefield? Picture a deep strike mission in 2045. The NGF leads a formation of unmanned remote carriers. Satellites feed live data to the combat cloud, identifying enemy air defenses. The NGF's AI suggests a route, the remote carriers jam radars, spoof missiles, and drop payloads. The NGF silently eliminates a high-value target using a stealth cruise missile. All this happens in minutes, with the pilot more of a battlefield coordinator than a trigger puller. That's the kind of integrated, fast-paced, multi-domain warfare FCAS is built for. In short, the future combat air system isn't just a new fighter. It's a complete reimagining of air power. A fusion of stealth, speed, autonomy, and intelligence. A digital air force in a box. And if it delivers on its promise, it won't just keep Europe safe. It will redefine what it means to rule the skies. As the global race for 6th-generation air superiority heats up, FCAS stands as a bold statement that Europe won't be left behind. It's not just about building the most advanced fighter. It's about shaping the future of war. Whether FCAS will live up to its ambition remains to be seen. But one thing is clear. The sky is no longer the limit, it's just the beginning.